Welcome back. In our previous video, you can recall that we looked at a homogeneous differential equations. And we said that a homogeneous differential equation is always in a form whereby when you do the substitution of lambda of x and lambda of y, you can get when you attach the lambda to the x and the y, and you factor the lambda out, you get lambda raised to the power of what? 0. And you get the function in terms of what? X and y here. And when this happens, then we say that the differential equation is a homogeneous. Alright. Now, one thing to take note is that when a differential equation is given for you to solve, don't forget that we have first looked at separable differential equation. That was the first method in solving a differential equation. And the second method that we look at it is, what if it's not separable? Then we check if it's homogeneous. And we have already discovered that, and we see how to verify whether it's homogeneous or not a homogeneous. Now that we are done with that, we are coming to the third technique or the third method in solving a differential equation, and that is non-homogeneous equation. Non-homogeneous equation. So the question is, what if it's not homogeneous? What if it's not homogeneous? So, in other words, another thing that we can use to replace non-homogeneous is equation reducible to a homogeneous equation. Equation reducible to a non-reducible to homogeneous equation. Equation reducible to homogeneous equation. Now, you can recall from your homogeneous equation how we solve it. It's the same thing that we are going to do here, but here the equation that we are going to give to you is not homogeneous. So we transform it back to what? A homogeneous equation. And that gives a homogeneous equation. Then you resolve it in the idea of solving a homogeneous equation. That is, you letting y to be equal to u of x, then like that, then we get to that. Very good. So, which of these equations that is non-homogeneous? So let's look at that equation. For instance, if we have a dy dx or a function of x in terms of y, and we get it to be equal to ax plus, let's say, by plus c, all this over a, let me represent here 1. Then we get x1 plus by1 plus c, okay, c1, let me make it 2, alright. You can record that in our previous example that we saw, we didn't get any question which was in terms of what? A constant. We were given some things like, let's say, x minus 1 divided dx is equal to x minus 1, let's say, 1 minus y. We were given some things like this to solve and others, but we didn't see the case. Sorry. Let's remove the constant. Let's say 2y, then let's say x. We did not see the case where we have a constant there being introduced. So in this case, we are going to look at the ones where there is an introduction of what? The constant. So then we look at how we can what? Solve that. And that is reducing A to a homogeneous equation. Alright. So all that we are saying is summarizing to this. Non-homogeneous equations are in the form this. So we are going to look at two cases here. We are going to look at case 1 or phase 1. Case 1. Then we go for case 2. In case 1, we are going to look at the case if the coefficient of this and the coefficient of this, let me represent here by 1, 2, 1, 2. Alright. When the coefficient of the x and the y for the numerator, you see we can get a1 over what? a2. So for the numerator and the denominator, if this is not equal to b1, b2, then we are going to apply this idea or this method in solving it. The first thing we will do is that we will substitute. We will substitute x to be equal to x1 plus y1 and y to be equal to y1 plus k. So wherever you see x, you put x1 plus h. Wherever you see y, you put y1 plus what? K. Don't forget, that is when the a1 over the a2, that is the constant, the coefficient of the x in the numerator and the y in the denominator, is not the same as the denominator, the constant of y1 and the constant of what? y2. And that is what we are talking about. So, to reduce it in the form, to reduce it in the form, don't forget that we are saying that we will reduce it to a homogeneous equation. So we are going to get the y1 over the x1 to be equal to, after the substitution, we are going to get something like ax1 plus by1 over a2x2 plus b2y2. We are going to get rid of this constant. We are going to get rid of this constant and pick only this part to be our homogeneous equation. So you see that this equation is going to be reduced to this form. It's going to be reduced to this form. And when you have this, then it means that you can solve it by the idea of what? A homogeneous differential equation, whereby you let y to be equal to ux, then you move on like that. Very good. Then we will be also getting, after that, we will pick the coefficient of the x1, then here will be a2, then the b1, that's the coefficient of the y1, the coefficient of the y2, which is what? b2. Then you find the determinant. And when you find the determinant, you should be getting 0 here, because we are saying that if the coefficient of a1 over a2 and a b1 over b2, if it's not the same, then we substitute this to that, then we pick up this. When we are trying to continue, you get to know what this means. And after that, we are going to use the coefficient of this and this Then you find the determinant of it. And when you find the determinant of it, you should be getting 0. Alright. So that is what we have for the case 1. Let's go to case 2. In the case 2, it's so simple. In the case 2, we are going to look at the case whereby the A1 over A2 is equal to B1 over what? B2. So that's what we are going to look at it now. So case 2. Case 2. What if A1 over A2 is equal to B1 over B2? If that is equal to that, that means that we can get the Y1 over the S1 to be equal to, or the Y over the S to be equal to A S plus BY over lambda AS plus BY plus C plus C. So when that is equal to that, then that is what we are going to get. Alright. Don't let the lambda here confuse you. The lambda here that means that for it to be equal to, sometimes you need to even factor something out, okay? Because if you have x plus y over 2x plus 2y, we can factor this constant 2 out, alright? So that the numerator here will be the same as the what? The denominator. So sometimes that is how we should let it be. Then we can put, so this is there for a general form. Then we can put Z, you can choose any alphabet that you like. Then we can put Z to be equal to AX plus BY over AX, AX plus what? BY. AX plus BY. Knowing that here will be AX plus BY, so here will be Z and here will be Z. Exactly. Alright. But the case, this is the case that A1 is equal over A2 is equal to B1 over what? B2. That means that we can factor something out and do a substitution to this. But if this is not equal to this, in other words, that means that you can never do any factorization here for the numerator here to be the same as the what? The denominator here. So that's that for that. So this is for the case 1. And that is for the case 2. Don't forget that in the case 1, after reducing it to this, you will find the determinant, but that determinant, the result should be given to you what? 0. Alright, the result should give you 0. And the case 2, when this is equal to this, that means that we can factor something out and do the substitution to it. So here we are going to get B plus C, then here we get lambda is B plus 1. Very good. So let's look at how we can go through such question. Equation reducible to homogeneous. In other words, non-homogeneous equation. Don't forget any of the steps, alright? Don't forget any of the steps. And case 1 is not another method to case 2. Alright, very good. Look, if the coefficients are not the same, you cannot apply it. So you go for another one, case. That is what it means. So it's going to be interesting here as we go through our first question. Find the general solution to the equation. Know what the general solution means. Find the general solution to the equation. Y is equal to x plus y minus 3 over x minus y minus 1. Very good. Now, let's assume this question is given to you. Forget the case that we are looking at non-homogeneous equation or equation reducible to homogeneous equation. Let's forget that. Now, you know of 3 methods. The method 1 is separable, homogeneous, and non-homogeneous. So if you are to find a general solution to the equation like this in your handout, which method will you go by? You can see that for separable, there is no way that this can be separate for you. No way. And also, for homogeneous, looking at the case, if it is homogeneous, you can see clearly that this is not homogeneous. Yes, because when you do the substitution, let's say let y be equal to u of x, then you take the derivative, or not even in that way, sorry. When we attach x by lambda, y by lambda, can we do a factor? Can we factor something out? Let us do lambda is here, lambda is here, lambda is here, lambda is here. You can see clearly that with this, you can't factor lambda out here. And you can't factor lambda out here because the lambda is not attaching with the constant here, and the lambda is not attaching with the constant here. So you cannot factor lambda out to get lambda over lambda, which is lambda raised to the 4 0, for it to be a homogeneous. So in this case, then we have to reduce it to a homogeneous equation. We have to reduce it to what? A homogeneous equation. And that is why this method comes into play. Alright. So, how do we go about it? First of all, we let x be equal to, don't forget x1, don't forget x1, really, it's very important. x1 plus h, then y1, y is equal to y1 plus a. Why are you bringing x1, y1? Because this x is not the same as this x, and this x is not the same as this x. Don't forget that. Very good. Then from here, what do? We do substitution. So y is equal to wherever you see, sorry, here is y prime. So you know that y prime is equal to dy over 1. Yes. So wherever you see x, you place it by this. So we get x1 plus y plus, wherever you see y, you place it by this. y1 plus y, k, minus 3. Yes, you have to put it. Then here we get x1 plus y1, oh sorry, plus y, plus y minus y1 plus a minus 1. So now let's go and simplify it. When you are simplifying this, you are going to get x1 plus h, y1 plus k minus 3. All this over x1 plus h minus y1. Don't forget this negative affect the inside, alright? Never forget that. So you get negative k minus 1. Now watch. What we said is that when you reduce it to homogeneous, the homogeneous is going to give you something like this. The homogeneous is going to give you something like this. AX1 plus BY1 over AX1 plus BY1 S. This one will be the 1, 1, this one will be the 1, 1. Right? 2, 2. We are saying that we are going to get something like this. That means that we have to bring this to this side so that after the S1, the Y1 will come. Then after the what? The S1 here, the Y1 will come. I hope it's clear. So let's bring it to that form. There is one thing I forgot to also remind you. Will this question fall under? Now we know that since the constants are here, it's going to be what? Equation or no homogeneous what equation. So we are going to reduce it to homogeneous. But we have two cases. Is it falling under case 1 or the case 2? You can clearly see that the coefficient of A1 here is 1. A1 here is 1 over A2. And the A2 we have here is 1. Now, is it going to be equal to B1 over, is it going to be equal to B1 over B2? The coefficient for B1 here is 1. So the coefficient for Y here, which is giving B1, is 1. Oh, very good. But here it's negative 1. The B2 is negative 1. This means that this is not equal to this. In that case, it falls under case 1. That is why we are solving it under case 1. In fact, I'm taking my time to give you all the techniques under this part. So, now also don't forget, right after replacing x by this, y by this, you change it to dy, dy, dx, dy, dy1 over the s1. So that is that. So now dy1 over the s1 is going to be equal to s1, then bring this one here, plus y1 plus h plus k minus 3. Very good. I hope that is clear. S1 minus y1, then plus h minus k minus 1. Very good. So here we are going to bring out the homogeneous equation and also our determinant. So here the y1 over the s1 is going to be equal to thing. Hope you can see that. Alright. Plus y1 over s1 minus y1. Yes, because we are saying that's exactly that. Because we are saying that when you, with that one, when you do, you are going to get something like, we are saying that you're going to get something like AS1 plus BY1 over AS1 minus BY1. So that is what we have here. So this is the homogeneous equation. Then which one is going to be the determinant? The determinant, which, no matter what, is going to be equal to 0, is this part, is this part, is this part. That means that if negative is here, it will affect whatever is there. So this forms the determinant. That is why here I said, send this to this side, bring this to this side, so that it will be in the proper form. So here we get h plus, so here we get h k negative 3. How do you know how to write the determinant? Don't be writing it like this, don't combine it. Then here will be h negative k negative 1. So that is that for that part. That is that for that part. Very good. So, alright, so that's what we have. You can bring, you don't worry, you can bring this one, this to be here, minus that. Very good. So that is what we have for that. So what we are going to do is that, don't forget that, with this, we are going to solve it homogeneously. But with this, if this is equal to 0, don't forget this is 2 by 3. If this is equal to 0, then we can solve it homogeneously. We can solve it simultaneously. Alright? Because what we have here is something like h plus k minus 3, h minus k minus 1 equals to 0, 0. Hope you can see that. So we can equate the numerator h plus k minus 3 to be equal to 0. Then h minus k minus 1 to be equal to 0. Then we solve this one simultaneously. So you know how to solve this simultaneously. You can do elimination method. Add this to this, you get 2h. Add this to this, you get 0. Add this to this, you get negative 4. Sorry, here negative 4 is equal to what? 0. So here clearly we are going to get our, we are going to get 2h is equal to 4. Divide both sides by 2, you get h is equal to 2. And when you get h, when you get your h to be equal to 2, then you take any of the equation, then you're going to get the substitution. And when you do that, your k is going to be 1. You know that already, okay? You can do the substitution here or here. So this be the equation 1, equation 2. Alright? So we add to get this. Very good. Now, after getting your h and your k, don't forget, we are not going to use it for now. So we keep the h and the k somewhere. Then we come back to the homogeneous differential equation. So we can say that this is the homogeneous differential equation. So it's not that we are getting rid of, or we are getting rid of the use of the constants here. You see, it is affecting our h and our k here. Very good. So we come back to this. We come back to this. So there is something that you don't need to forget it. Let me write it here for you. First, S1 is equal to S1 plus what? H. Then Y is equal to Y1 plus K. And we know our K is equal to 1, our H is equal to 2. How we can see from there? Yeah, you don't need to forget this. We will come back to the use of it. So let's do everything. So now, we know that we have the y1 over the s1 is equal to s1 plus y1 over s1 minus y1. Let me clean the rest. Very good. Let's continue. So here we solve this using homogeneous. So let y1 be equal to ux. But here it's not just x, but x1. Don't forget that. Then we take the y1 over the x1. Alright? Even here, yeah, the y1 over the x1, and that is going to be the product rule. leave this, differentiate this as equal to x, you get 1 plus u the y1 the x1. Is that not it? Sorry? Leave this, differentiate this, you get 1 plus, now you leave this, what am I doing? Now you leave the x1, then you differentiate this, du, the x1, very good. So instead of writing this, we write this for the left hand side, then we repeat this. You know how to solve this already. So u plus x1 du dx is equal to the right hand side, x1 plus y1 over x1 minus y1. Then we let this stand alone. x1 du dx is equal to we have forgotten something. And what is that? Right after here, we don't repeat the y again, but we replace it by what? U s1. Alright, so let's read those parts. So here is going to be u s1, the same way as how we solve homogeneous equation. Don't be confused. So here, let's move on. S1 plus US1 over S1 minus US1. Then you send it to this side, you get minus U. Here, the idea is that we want to achieve the same denominator. So S1 du S1 is equal to S1 plus. That is what we have. Very good. So here we have been able to achieve the same denominator. Alright. So what we do here now is that we can combine this since we have achieved the same denominator. So S1 du S1 is equal to here S1 plus U S1 minus U. This multiply this. Or let me repeat that part. S1 minus U S1. All this is over S minus U S1. Hope you can see that. Very good. So here we get S1 du dx1 to be equal to S1 plus US1 minus US1. This affects the inside here also. Plus this to this, you get U squared S1. All this is over S minus U S1. Very good. Now, having this, we can factorize something out in the numerator here. And what is that? And even before that, critically, you can see that this will take away this. Alright? So we are going to be left with S1 du over the S1 to be equal to S1 plus U squared S1. All this over S1 minus U S1. Here we can factor S1 out. S1 du dx1 is equal to S1 out 1 minus U squared. All this over S1 1 minus U. I hope you can see that. Very good. And here this cancels it. So we get S1 du dx1 to be equal to 1 minus U squared over 1 minus U. So that is that for that. So you can see that we have reduced everything to this form. So we continue with it. Here we can see it is not separate. We can see that we have transformed from non-homogeneous to homogeneous. That's the first thing. Non-homogeneous to what? Homogeneous. And from homogeneous to, and from homogeneous to what? A separable differential equation. So here we can separate it. In what way? We can see that here we can get du here to be equal to, then the dx will come to this side, dx1. Here will be 1 over x1, alright? And we take the reciprocal of this, then we get 1 minus u. You know how to do this already. We have already done that. U squared. So 1 minus u over 1 minus what? U squared. So that is that. Now it is separate. So from here, what do we do? You see, it's a gradual process. It's not difficult. Here you are at calculus 2. So welcome to calculus 2. So here, we integrate both sides. As respect to u and as respect to what? X1. So you can see that it's not difficult. So welcome to calculus 2. So the journey continues. So here you can see clearly that this side is just simple. We just need S1, but this side. Alright. So we get integral of 1 minus u over 1 minus u squared du to be equal to ln S1 plus C. But what about this side? That is what to be under discussion. Is there any mistake somewhere? Is here supposed to be plus or minus? Because it seems I'm getting different in here. But I have made my back. But let me check first. Oh yeah. When the negative affects the inside, that place will be plus. Oh, we even made it plus, but when factorizing the x1, then we change it to minus. It's plus. So here is plus, and here is plus. I'm sure you also see that. Here is plus. Very good. Now, here that we are, we can solve this in two ways. Alright? Let's bring that out. 1 minus u over 1 plus u squared du. We can solve these two ways. We can say that with this, you see, use and pushing will not work. Alright? Use and pushing will not work. So let's split this. So when you split it, you are going to get the integral of 1 over, how we can see that? 1 over 1 plus u squared du minus, because it's 1 minus, hope you know how to split it. Then we get the integral of u over 1 plus u squared du. So you can see that this one will be used as pushing. Because when you set this to be equal to u, the variable u that will be left will come and cancel this. And with this, you can see clearly that this one is tan inverse. So just go your way, don't do anything difficult. Alright? Be good in your calculus. Go back and revise more. So here, you can see that here is tan inverse of u minus here we can let, when we let u to be, we know u, so let's make it w, 1 plus u squared. The w is equal to 2u du. Or we can see that 2u du. So what will be the w? The w What will be the u? The u will be equal to the w over r. Divide both sides by 2w. So here will be 2w. So by substitution, we get u over w here multiplied by the w over 3. So w cancel u rather u. So u cancel u. Then half will come out. So we are going to get. I don't want to be doing everything, you know this already. Yeah, we are going to get 1 over w. So we get ln w. So here we are going to get half ln w, and this is w. Very good. So let me clear up this. So when you do this, alright. So when you do this, you are going to get minus half ln 1 plus u squared. 1 plus u squared. 1 plus u squared. So that is what this, the left hand side is going to give you. So let's combine all. So to combine all, we get tan inverse of u minus half ln 1 plus u squared to be equal to ln s1 plus c. That is what we have for that. But here we are not done. You know that we can simplify this. Alright? We can say that let's write this as ln c. So when we write that as ln c, we can see that here we write tan inverse of u minus 1 over 2. Don't forget this though. It will come in. Don't forget. It will come in. You watch. Over 2. Don't forget that also. We can write this as ln 1 plus u squared power half is equal to ln c s1. Okay, ln c s1. And we can also send this to this side so that we can combine this and this. So we get tan inverse of u is equal to ln c s1 plus ln 1 plus u squared half. Then tan inverse of u is equal to ln this will multiply this, so cs1 will multiply. How are we going to see that? So this, since it's flat, so here we get 1 plus u squared to the power half. Okay, very good. Then we take the natural log on both sides. So natural log, this cancel this. So we get, yes, it's just one question. So we get, CS1 is equal to, and we have a lot of questions also to solve. One plus u squared power half is equal to e raised to the power tan inverse of u. So this is where we have arrived. But don't forget, that is not the final answer. What we are looking for is that we have to find a general solution. But here, the general solution is in terms of what? U. So in this case, we have to go and do the substitution back. Alright? What is U? We know that if y is equal to ux, then u is equal to y over x. So by substitution, watch. See, we have another substitution to do here. 1 plus u is y over x. So we get y squared over x squared. Alright? And don't forget, this is even s1. So y1. So this is 1, 1. Yes, don't forget, subtract 1, 1. All to the power half is equal to e raised to the power tan inverse of y over x. And that one is y1 x1. And that is also not the general solution. Because the general solution cannot be in terms of x1 and what? y1. So we go and look for what this x1 and y1 means. So okay. So if x is equal to s1 plus h, then s1 will be equal to s minus h. And if y is equal to y1 plus k, then y1 will be equal to y minus k. But I want to write anything. But h is 2 from here. K is 1. So by substitution, s1 is what? S minus 2. y1 is what? Y minus 1. So finally, by substitution, C is going to, we are going to get, we should have even reviewed this one some more before the substitution. But you don't worry. Let's do that. Let's do that here. Let's do that here. Let's apply some more algebra. Yeah, but we know this. We will bring it back later. But wait, we want to do something. We can use what we have here, okay? Here we can get CS1. Then here we can bring the square root, alright? To maintain the same denominator, we can make here x squared over x squared plus y squared over x squared. I hope you can see what we want to achieve. And this is equal to e raised to the power tan inverse of y1 over what? x1. Alright. And here is cs1. Because if you don't review this before you come and do the substitution, it will be something bizarre. Alright, it will be nasty stuff. So you get x squared plus y squared over what? X squared. It's equal to e raised to the power tan inverse of y1 over what? x1. Very good. Very good. So don't forget that here is 1, 1, 1, 1, 1, 1, 1. Alright. And now look at something. When you take the square root of this, I'm going to do something right now. cs1 multiplied by x squared 1 plus y1 squared. Alright. And when you take the square root of this, get x squared 1. So here is the square root. Alright. So this will cancel this. And the x that will be left, the x1 will come and clear off this. So you can see there will be no numerator here. Sorry, denominator here. So we get c square root of x squared plus y squared is equal to e tan inverse of y1 over x1. So that is the simplest form of this. That is the simplest form of this. So we can now bring back x1 and what y1. And what is that going to give us? So finally, we are going to get C. Our general solution is going to be C. X1 is what? X minus 2 squared plus y minus 1 squared. Because e raised to the power tan inverse of y1, what is y minus 1 over x minus 1. Alright? Wow! Woo! So that is going to be our final result. And that is the general solution for the differential equation that we have. Thank you. See you in the next video to solve another question.